All right, so let's take a look at the measurement system that we use for chemistry and physical science. Okay? And the reason why we need to worry about that is because chemistry is all about quantities, which always involves a number and a unit. Now, the SI system, or System International unit, right, is one that we can use across different countries. Okay? So the key question here that they're asking is, what are the 7 or what are the basic units of measurement in the SI system? Okay? The standard system used by scientists is the SI system, which we just said, right? We use it so that we can stay consistent from country to country. In fact, sometimes when you use one system in one country and another and you convert them over, there's mistakes made enough that it can cost lots of money. I remember a story in the past where the space shuttle had some slight differences in the way it was made in one country with its system of measurement and the way it was made in another country with its system of measurement, but they didn't fit together properly and it caused millions of dollars of damage. Okay? Scientists use SI units to measure length, volume, mass, density, temperature, time, all kinds of stuff they use it for. All right, so let's take a look at the measurement system that we use for chemistry and physical science. Okay? And the reason why we need to worry about that is because chemistry is all about quantities, which always involves a number and a unit. Now, the SI system, or System International unit, right, is one that we can use across different countries. Okay? So the key question here that they're asking is, what are the 7 or what are the basic units of measurement in the SI system? Okay? The standard system used by scientists is the SI system, which we just said, right? We use it so that we can stay consistent from country to country. In fact, sometimes when you use one system in one country and another and you convert them over, there's mistakes made enough that it can cost lots of money. I remember a story in the past where the space shuttle had some slight differences in the way it was made in one country with its system of measurement and the way it was made in another country with its system of measurement, but they didn't fit together properly and it caused millions of dollars of damage. Okay? Scientists use SI units to measure length, volume, mass, density, temperature, time, all kinds of stuff they use it for. Base units you measure directly. And there are 7 base units for the SI system: length, mass, time, electric current, temperature, amount of substance, and luminosity. The symbols are present there. They show you in each one, and they show you what each one of the base unit actually is. So for length, it's meter. For mass, it's kilogram. Time, it's second, and so on. We're not using electric current in our studies, nor are we using luminosity or luminous intensity, so we don't have to worry about either one of those. What's new when you deal with chemistry is the amount of substance, which has the symbol N, which stands for mole. Mole is the base unit for the amount of substance, and that's important in chemistry because we deal with things that are very small that have lots and lots of numbers. Length is how long something is. The basic unit of length in the SI system is called the meter, or M. Centimeter, millimeter, kilometer, those are ways we measure length. Centimeter and millimeter are small, and they're defined. Centi is 1/100th, millimeter, milli is 1,000, and so on. How do you measure length? What kind of tools do you use to do so? That's what's next. Okay? Mass, the amount of material an object has. Okay? The basic unit for mass is the kilogram. It's the kilogram, not the gram, but the kilogram. The reason why we call it the kilogram, because a kilogram is kind of close in size to the pound. 1 kilogram equals 2.2 pounds. And kilo means 1,000 when we talked about length, and it means 1,000 when we talk about mass. So how do you measure mass? Okay? Temperature is another base unit. Okay? There are 3 different scales for temperature, and temperature is the measure of kinetic energy or molecular motion. Okay? The 3 different scales are Fahrenheit, Celsius, and Kelvin. Fahrenheit, it's established because one of the first scientists to go ahead and get a thermometer work consistently was Fahrenheit. So he has his own scale named after him. There's not a lot of basis for what his numbers mean. And it's been pushed by the British Empire because Fahrenheit was the system that they were using when they decided to take over half the world. In the SI system, we like to use Kelvin or Celsius. Celsius makes sense because it's based on the boiling and freezing points of water. 0 degrees Celsius is where water freezes or melts. 100 degrees Celsius is where water boils or condenses. Okay, and then it gives some basic things about normal human body temperature and normal room temperature. Okay, for the SI unit, we like to use the Kelvin scale. It's based on absolute zero. 0 Kelvin is as low as the number can go. There are no negative numbers inside there. It's where all molecular motion stops. How do you measure temperature? Volume is not a base unit. It's actually made up of other units. For example, when you measure the volume of a cube, you measure the length of the side, the width of the side, and the height of the side. Length times width times height. That gives you volume. You're using a ruler to measure those things out, which makes each one of those, the length, the width, and the height, as crazy as it sounds, a length. Okay? The basic unit for volume is a liter. Milliliters is what we tend to use when we have something small. Milliliter means the exact same thing as a centimeter cubed, or cc's, cubic centimeters. Okay? A cubic centimeter is equal to a milliliter. And on the bottom, how did we get the volume or liter in the first place? Well, we went ahead and we measured out a cubic decimeter, which means it was a decimeter on the height, it was a decimeter on the length, it was a decimeter on the width. We multiplied them together, and we got 1 cubic decimeter. We made a mold of it. We call that a liter. Density, on the other hand, is how much material mass I can cram in a certain area or volume, right? A certain space or volume, not area, but certain space or volume. And it's equal to mass divided by volume, okay? So then we work a little example here. We take 10 grams, which is the mass, divide by 10 milliliters, which is the volume. We get 1 gram per milliliter. But we'll do more problems with density later, okay? It's significant because, or 1 gram per milliliter is significant because that's the actual density of water. Pure water is 1 gram per milliliter, which is important because when you go ahead and you put something in water and it sinks, it's got to be more dense than water, or more dense than a larger value than 1. And if you put it in water and it floats, it's got to have a value less than 1. Okay? Now the process we use to go ahead and convert things back and forth between one unit to another is called dimensional analysis. We convert from one unit to another. That's what dimensional analysis allows us to do. We use something called a conversion factor, which we'll explain later. The conversion factor, when written as a fraction, one side over the other side, okay, it's equal to 1. That's important because you're always multiplying by 1 when you do dimensional analysis. Okay? These are some prefixes for the SI units. We usually use mega all the way down to pico. And mega means a million. Okay? Kilo means 1,000. Okay? Picos, on the other hand, is very small. 10 to the minus 12th, or 0.00011 zeros and a 1. And on the right-hand side, you can see different ways to write all the same number. We'll talk about scientific notation at a later time. Okay, so when we set up these conversions, what we want to do is write a conversion factor. That's what we're doing to start with. And so what we always do is take the prefix and define it. In that list before, where we had the SI prefix conversions, these are really definitions. Kilo means 1,000. Mega means 1 million, and so on. Okay, so when we go ahead and we go back to where the SI prefixes are concerned, when we write them out, we see that 1 kilogram equals 1,000 grams. The 1 is written with the prefix. What the prefix is equal to is written on the other side. So kilo means 1,000. So 1 kilogram equals 1,000 grams, or 1 kilometer equals 1,000 meters. And the same thing works for the other prefixes. Picometer, 11 zeros, a 1, and a meter. Okay, well, the 1 goes with the prefix. 1 milli, right, and what it's defined as, right, on the other side, 0.001 on this side. And they're both liters, so we keep them on both sides. Okay, and with this dimension analysis, we do a couple things to do it. The first thing we do is we always identify what we have. We call that our given, and we want to end up with. Okay, and we use a conversion factor to go ahead and go from one end to the other. Okay, we write out our conversion factors, the one with the prefix, like we did in the last part. Okay. And what we want to do is set them up so that the conversion or the units cancel. When we have them all cancel out, we want to go ahead and multiply all the top, multiply all the bottom, divide the top by the bottom. And we should have the right unit at the end, so we should be able to check it and make sure we have the right answer. Okay? And this last part shows what's going on here. When I go ahead and write centimeters cubed in the numerator on one side and multiply it by a unit that has centimeters cubed in the denominator, they will cancel out. And they will no longer be part of the system. They are what we call factored out. And what happens is the gram is left over in the numerator, so you write it in the answer. Okay, so this is the basic starting point of any kind of physical science. You should look at how to measure things before you go into the laboratory so you have a good clue of how things work.